Introducing Python Pandas.
Ho ho ho!
If you did want the full workbook, head over to my website, the link will be below. Add it to your cart, buy it now, and I promise you'll get a ton of value from it. Let's get right into it. First, having it installed the Anaconda distribution of Python under the Jupyter Notebook, I'm going to run that in my terminal. Once open, I'll import the file which I've downloaded, and we'll go through some of it right now. So, it should be in my downloads. Now we're going to start off with just introducing what Pandas even is. I'm going to walk you through my process, knowing Excel very strongly, using a bit of Power BI, a touch of SQL, but not really understanding why anyone would use Python or what Pandas even is. Now I'm not going to touch the full workbook. If you do want to see that, as I say, check it out down below. But we will be going through the fundamentals today, meaning we'll be covering all of this brilliant content all the way up to filtering. Everything after this I have hidden and you'll find in the workbook. So let's get to it. Now what even is Pandas? Pandas is a powerful tool used for Python. It allows you to work with structured data sets, and to be honest, it's the most of data analysis in Python. It is very core to what you'll be doing. But how do you even get it to work? Well, in the first place, go to your terminal or your CMD environment, the same way that we had run Jupyter Notebook, and type this, pip install pandas. Once done, it's installed, and you're ready to import that into your Python script. Here we're using Jupyter Notebooks. To do that, you'll type this, import pandas as PD. Now PD is just a convention. It's what we call pandas for short, and it's how we'll reference it later on in the code, as you'll see here. So to run that, you can either head to the top and press run, and you'll see it loads like this, or hold down shift and press enter. And there we go. Now, Pandas provides two main data structures, a series and a data frame. These two types of structures you should be aware of, just keep the terminology in mind. So a series is a one-dimensional array. Now what does that even mean? Let's say we had a list of items called list, and what list was, is it was just the numbers, well, here. If we were to print a list, it'll be like this. It's not something we can work with in the form of data. So we'll turn it into a series, like this. This converts this list into a series with the method pd.series. And then we print it. You'll see here this transforms it in a way, but not in the same way that a two-dimensional labeled data structure would have. Something more like an Excel spreadsheet that you'd be more familiar with. That's what we call a data frame. Now a data frame table is more like this, something a lot more familiar, and it's really most of what you'll be working with, but just bear this in mind. A data frame, you have all of these columns, rows, each indexed as this was above, although it wasn't in a column and row structure. This tabular format has name, age, and city. Now we created this from a dictionary. We assigned these names in the list to name, the column, these ages to age, and these cities to city. Then we said df for data frame, again, we love to shorten things in Python, is equal to pd pandas dot data frame, this data here. And then we just printed it. What we could also do, being that it is now a data frame, is we could do df.head. This will show it in a more tabular format with the rows and columns, and from this, which we'll get to later, is really the basis of data analysis in Python. Now that we've covered those basic structures, let's get into what you even do with that, because typically you're importing data that's already been stored in an Excel file and working from that. So, basic operations and attributes. Pandas provides various operations and attributes to work with both series and data frames. As we just saw, .head shows the first 4 rows. Now you'll note it says 0 to 3. That's because indexing, or the count along the side, starts at 0. Now if there were 10 rows, rather than defaulting to the first 4, we could do df.head, and this would show the top 10. You can see here there isn't more than 4. You could also show the last few with df.tail. Easy to remember, head being the top, tail being the bottom. Now if you want to very quickly, and here's why you would use Pandas or Python over Excel or otherwise, is that you can very quickly generate a lot of key information, like this. To learn more about this data frame, I ran df.info. This method, making sure I finish again with the brackets, gives you for each of the columns, name, age and city, how many null values there are. Now I know each has 4 values and all 4 are non-null. I could also see the data type and I could change that if I needed to. Age is an integer. Now if I wanted it to be a decimal, I'd make it a float, whereas city and name are objects. Again, for all the numerical columns, with this data frame it's very small and we only have 1 of age. You can do df.describe to get some descriptive or describing statistics. We have the count, which we know is 4, the mean 32, standard deviation, the minimum being 25, the biggest number being 40, and it allows you to very quickly grasp the data. Let's see the size of the data frame. Now for these 2 ones here, it's important to note that I actually don't finish with the curly brackets. It is simply the syntax of Python. Now there are method and attributes, but really just know that when you're typing these, it doesn't have parentheses at the end, and if you try to, it simply wouldn't run. Moving down, we can see the shape. So the shape is the size of the data frame. How many rows? 4, as we know, and columns, 3. And then moving down to columns, we can see that if you call it with df.columns, rather than scrolling up each time, counting them, remembering them, going back down, or reloading the data frame and the head each time, just look at what they are. We know there are 3, 1, 2, 3. So run it with df.columns to get all the names laid out. Now, that's all great in theory, but let's get into the meat of this. How do you really use Python Pandas for data analysis? Well, you'd be using it from a CSV file, an Excel file. You might go fancy and use a SQL database, but typically it'll be an Excel or CSV. This is the kind of setup you would get data in from, say, Kaggle, an online source for data sets. And to load it in, after you've imported Pandas, as we showed at the beginning, you simply do df, which is convention, data frame, equals pandas, pd, dot read in the CSV, or dot read underscore Excel, within the brackets, just the name of the file. So make sure to include that final .csv or XLSX if it is an Excel file, and within those single brackets, just put the name of the file. From there, we could then call it with df.shape, head, and otherwise. What if you wanted to check for missing values? Well, you do df.isNull.sum. Now our data frame at the minute, because I haven't run this cell above, is what we had at the beginning. So you can see in each one of these columns there are no null values. Great way to quickly check. Now, if you wanted to drop rows with missing values, you drop NA, in place true. If you didn't have in place equals true, when you then go to another cell and run it, it doesn't actually make a permanent change. It only does it for this cell. So in place means it does it throughout the workbook. Equally, you could fill these with a specific value. Say instead of value, you could put 5, or commonly we put the average of that column. I briefly touched on data types earlier, and when loading in the data set, you can actually change them. So I'm going to make age to be an integer rather than a float or otherwise, and it will update that. Whilst null values are a problem, as are duplicates. Let's count how many duplicates our dataset has. None. Expected, it's very small. If there were any, we could remove them. And you see, it hasn't done anything because there is nothing to remove. This one is very interesting. So again, let's zoom out a bit here. And I'm going to type in df.columns. Now I can see they're called name, age, and city. So I'm going to change this. Name becomes full name, and age becomes years. I'm going to make in place true, so when I run that and go back again, you'll see these all update. And there we go. It's a very quick and fast tool for working with it. It is a bit different to Excel, and it can take a moment to grasp that you're not going in and manually writing all of these to each cell, but you're updating it across the data frame in Python. As you get more used to it, it does become quite quick. Now, indexing and slicing. You can actually select rows and columns by their indexing labels. Now, we had mentioned indexing earlier when we said it starts at 0 and goes down accordingly. Let's say we wanted a subset with a specific row label and column label. You can select those based on the titles or the indices, or based on a specific value, which you may be familiar with if you have used SQL, the structured query language. So we're calling our DataFrame subset because you don't have to call it DF, and we don't want to update the DataFrame itself, we just want to create a new one from it. But you could call it anything. So our subset is going to be, now let's delete these for a moment, DataFrame, within that, the column age greater than 30. So once that is run, if we then take a look at our data frame, you'll find that it only shows the ages greater than 30. Now, why hasn't this worked? The reason it hasn't worked is because we changed the name of that column. So going back up here, it's now called years. So let's put that in. It's important to bear these in mind. So if we then do subset.head, there you go, just these two people here were greater than the age, 30. And to finish it off, let's do filtering. Again, something familiar if you have used SQL before. We can filter it based on conditions, such as whether city is New York, and we can then sort it by age ascending, remembering that this is now called years. Let's have a look at these filtered and sorted data sets. You can now see it only shows where it is New York, and sorted data shows as before, but just like this. Descending, ascending equals false, so that it's descending. If you do want to check out the workbook, again, head to tobygeeson.com/services. Check out our store. There's a lot more information, including some tasks in here as well, some projects for you to work on, and some sample data. So all the best and good luck.